Hello my dear students, and welcome once again to another video for our class in object-oriented programming. In this video, we are going to talk about the concept of polymorphism. Now, the concept of polymorphism can be difficult to grasp at first. In fact, I myself had difficulty understanding the concept in the early stages of studying object-oriented programming. However, once you grasp what it really means, you'll find that it is actually an easy concept. Polymorphism is considered one of the important features of object-oriented programming. That is why it is crucial that you fully understand it in order to leverage the power you can yield with it. So what is polymorphism? The word polymorphism means having many forms. In simple terms, we can define polymorphism as the ability of something to be treated in more than one way depending on the context. Real life example of polymorphism could be a person at the same time can be or can have different characteristics. Like a man at the same time is a father or a husband and an employee. So the person possesses different behavior in different situations. This is called polymorphism. Let's take a look at this analogy. Chaska is a student. Naturally, other people should treat or relate to her as a student. But what if one do not know that Chaska is indeed a student? How would that one person relate or treat her? Well, we can also treat Chaska as a person. This is an example scenario that explains the concept of polymorphism. In object-oriented programming practice, specifically in the context of inheritance, polymorphism provides the feature of being able to assign an object of the superclass with an instance of any of its subclasses. Let's take a look, for example, this class hierarchy. Here we have the class person as the superclass of student, employee, and priest. And working student is a subclass of the class student. So in this hierarchical structure, student is both a subclass and a superclass because student is a subclass of person and student is the superclass of working student. In this example, we can demonstrate polymorphism by assigning an object of the type person with an instance of any of its subclasses. For example, person P1 is equal to new student. This is a valid statement. Here, we created an object of type person called P1, but we assigned it to a new instance of the object student. Or, person P2 is equal to new employee, which is the same or similar to person P3 is equal to new priest. So here the class person has been assigned with three different classes in mind. The common among those three is that all of them are subclasses of person. You might also have, for example, a student S1 is equal to a new working student. This is also valid since working student is a subclass of student. Let's take a look at this case study. Suppose there is a community gathering and you need to have a program that will hold a list of the participants. Note that the participants includes employees, students, and some of them are working students, and priests, as well as other persons or other people whose occupation is not known, who would like to participate. How would you implement this? Let's take a look at the solution to this problem in a coding demonstration. So here we are once again in our Visual Studio Code editor. I have pre-written most of the code for the given class hierarchy earlier, wherein the class person is the superclass, and student, employee, and priest are subclasses of the class person, and working student as the subclass of the class student. As you can see here, we have the class person with the properties of name and address, with constructor to initialize both the name and the address, and a complete set of setters and getters, as well as some extra methods for the class person: talk, sleep, and work, as well as introduce, which will simply display the message "hello, my name is," and then the name, followed by "I live in," and then the address. Here we also have the employee, which extends person with additional properties of employee number, position, and salary rate, and the corresponding constructors, setters, and getters. This is very similar to the other classes, such as the priest, the student. Here, the working student is extending towards the student. So this set of classes here follow this particular class hierarchy. So now, in a main.java file, we have our main method here. Let's try and implement the problem, which is to have a list of participants in a community gathering, which is going to be a combination of many different people. Now, we cannot implement having an array, for example, of priest. You can say priest as an array, and say priests is equal to new priest. Say if we're expecting 100 participants, now we can, this will allow us to have a list of priests, but will not allow us to have contents that includes an employee or a student, let alone a working student. For example, if we do priest priest 0, priest 0 is equal to new student, like that. And say we have Alan of Tubigon, BHSRM 2. Okay, this is, as you can see, an error. It says type mismatch, cannot convert from student to priest. That is because this priest array is expecting priest objects. We cannot assign student objects into it. So let's just put this into another student st1, like so. And you cannot do that as well. What you can do, however, is you can add a priest in there. So if we are going to define a priest, T1, and that priest's name is Buenafe of Cebu, and what else we have? The parish is Santo Niño, and the order is diocesan. You can have a priest like that, and we can add it into our list of priests or array of priests. So we should not have we could implement the problem, the solution to the problem, by having an array of students, and an array of person, and an array of employee, and so on. But that is not very efficient. However, because of the power of polymorphism, we can instead create an array of person. We'll call this participants, and we're expecting, for example, 100 participants. Now we can actually add into the participants. For example, the first participant is a student. So participant 0 is equal to ST1. As you can see, there's no error. And participants, am I correct? Participants 1 index 1 is equal to P1. As you can see here, both these statements are correct. This is how you can yield the power of polymorphism. Here, since participant is of type person, which is a superclass of student and priest, we can put students and priests into the participants array because of the power of polymorphism. Aside from that, we can also add into the participants instances of employee as well as working student, and of course instances of the class person itself. For example, we'll add a class person, PR1, and let's say Edwin of Inabanga, like so. We can add it here, participants 2 is equal to PR1. And we can also add a working student, for example, Sheila of Tubigon with course of BSIT 3. Is it correct? Okay, we still have to add a room assignment, say room 3. Okay, and we can add that as well into our participants, like so. So now we can have a loop. We can do a loop to get all the participants to introduce themselves. So we'll have 0. Let's just stop until 4 because there's only 4 of them. And inside of here, we can call participants I dot introduce. All right. So if you run this program, we should have all 4 of these participants introducing themselves. So you have, hello, my name is Alan. I live in Tubigon. Hello, my name is Benafe. I live in Cebu. Hello, my name is Edwin. I live in Inabanga. And hello, my name is Sheila. I live in Tubigon. So it is working. That is the power of polymorphism. Now, you can also apply the power of polymorphism on parameters. Say, for example, we are going to have a method here, or a function, public static void, and say focus, and here we are going to have a person, and whatever we are going to do inside of this method, the point is we have a parameter which is of type person. And so let's just have it here. Let's make this person talk. So p dot talk, p dot work, and then p dot introduce again. Okay, we'll just do that. So we can also do that here if we want. We can say focus, and instead of asking for a person, since this is expecting a person, with the power of polymorphism, we can also put here a student like ST1. All right, and that is also well and good. Or any other instance of its subclasses can be placed here. So that's also another way of utilizing polymorphism. So now let's run this program. Let's see. So now after them all introducing themselves, there's also Alan is working, and hello, my name is Alan. I live in Tubigon. There's one that was not a work. Person work. This was not working. I don't know why, but let's go back to our main work. Let's take a look at output. Actually, Alan is working. The first one was not talk. Let's take a look at talk. Oh, it's the same. The introduce and talk are the same. Anyway, that's it. So that's how you can utilize polymorphism. So this was the talk. Hello, my name is Alan. This was the work, and then this was the introduce. Okay. So that is the power of polymorphism once again, and I hope you have understood the concept clearly. And as always, thank you so much for watching, and see you again in the next one.